Greetings, ninth graders. It is I, your fearless leader, Mr. Mortensen. I hope you are having a wonderful day, and I hope that you find this video to be very helpful. We are going to be doing quite a bit with inequalities, and so I'm going to cover a lot of the different materials that we plan to go over for the next coming week. So if you're catching this right around the start, don't worry. We haven't done all of this yet. Or if you're catching this more around, say, a quiz date or something coming up, then hopefully you find this to be very helpful. All right? But as of this point, as of me recording this video, we have not done everything that I'm about to cover. So keep that in mind, and let's go ahead and let's just start out with a couple of things. So let's practice with a quick review on some inequalities that we've been working with. Let's try an example of negative x plus 6, and we will say that this is greater than negative 9. Alright? Now remember, a lot of times with inequalities, even though it feels like half the time we're trying to say what it isn't or trying to give a bunch of different answers, we still treat it a lot like an equation. So we have our x term, and we have our plus 6, and then we have a negative 9 on the other side of our inequality sign. So we'll start off just like we would with any other equation, and we'll subtract 6 off of both sides. Okay? So negative 6 being added on to a positive 6, that's just going to add to 0. And that'll leave us with negative x greater than negative 15. Okay. Now remember, we can't claim that we have solved a problem if it's negative x. That's like saying negative 1 times x gives us some number that is greater than negative 15. So we have to be able to finish up here, and remember we're going to divide by negative 1. Sometimes this logic was used just saying, well, if you have this, then you're going to flip all the signs around. In this case, we just have to make sure that we're changing the sign for x. Alright, so x, and I'm going to write my positive 15 on the other side. Well, let's think about this now. We have divided by a negative number. So what that means to us means that our new sign is going to be augmented in the opposite direction. Now, instead of being aimed at the x, it's going to be going the other way. And let's actually review this a different way. Let's go ahead and try and solve it in a different fashion, and I'll show you why we have to be sure to change that sign. So let's rewrite it out again. We're going to go negative x plus 6. We'll have our greater than sign and negative 9. Okay. This time, instead of moving the x, instead of moving the 6, let's move the x to the other side. So we're going to start by adding x to both sides. Okay, so what that's going to give us is positive 6. The x and negative x will cancel. We'll keep our sign. Okay, there we are. Alright, and now, in order to get x by itself, we now have to add 9 to both sides. Alright. So we will add 9, and that's going to make our negative 9 and positive 9 add to 0. And so if we add 6 and 9 together, that gives us a positive 15 is greater than x. Which, okay, so let's see here. So we have our 15, we have our x, so we have sort of the same looking thing, but now, instead of saying x is less than 15, we have 15 is greater than x. So if we think about that statement for a moment, it's still saying that we're looking at all numbers that are going to be falling under 15. And so if we were to actually rewrite this with our variable term on the left, remember we'd still want to augment the mouth of our Pac-Man looking inequality sign here. We'd want to still have that aimed at the 15. So as we can see, we got to the same answer. But because of how we were able to do that without multiplying by a negative, we never had to actually switch the sign around. at least in any formal step. But notice that because of the way we solved it, we made sure that the sign still had to be augmented towards the 15. So that's why when we do those negative division steps, we always have to switch the sign around, so that we can always still kind of arrive at that same value. Another way of thinking about it, and just a quick review step here from something we talked about in class, let's think of two numbers. Let's take 4 and 2. All right, and let's make a sign that's going to tell us, is 4 bigger than 2 or is 2 bigger than 4? All right, we would choose 4 is greater than 2. Okay, well that's all nice and good. Now let's multiply both of these by -2. Okay, so we're going to multiply both sides by -2. Common step that we might do in arithmetic. -2 times 4, that gives us -8. And then -4. Okay, well 8's bigger than 4, right? So why would we change the sign? Keep in mind, we just changed our whole sign here. Is it better to be in debt for $4 or in debt to somebody for $8? Technically, the case of, well, we hypothetically have more money, once we get paid, this is kind of a smaller debt. That's the one that we would find more ideal.